Hello and welcome to another video on the React Native version 2, a course taught by Kadi Kraman. She's a software engineer that has a background on mathematics, and then she transitioned to work as a software engineering at Formidable, a social first creative agency, as a director of engineering of mobile services. And then now she's currently working at software developer at Expo, which is one of the features that help us to develop cross-border or cross-platform applications using React Native. So why this is important? Well, as a way to first understand what she is doing, what she has done, who is, why do I need to pay attention to her, and also this video is all about walking through the goal, the introduction of the video, as well as the setup and some basic components until it reached to the first section, which is navigation. So to speed up things a little bit, the entire goal of this is to learn how can we build React Native application, how can we build native applications using React Native. And the reason of using React Native, because this is something that is on demand in a lot of the companies. So first you need to have is Windows, or Linux, or Mac. In my particular case, you must have to have a Mac, because that will streamline the entire development process. If you don't have that, no problem, but especially if you're going to work with a company, they need you to have a Mac, or perhaps they're going to provide you. So what is React Native? This little intro is just as a way to understand how do we get here. So React Native is this library that allows to write its cross-native or cross-platform applications using JavaScript. Despite all of this jargon, the reason why we're using this is because since the mobile now is one of the most powerful devices that we can carry at our hands. So 50 years ago, roughly speaking, when the leading computing or the guiding computer used to send humans on the moon, the first human on the moon, right now our mobile device, we use or have over 100,000 times more computational power and 1 million times of RAM, of memory. So that is something crazy and beautiful. However, when you want to navigate through the browser on your mobile device, this is a suboptimal experience when you compare that with Linux or any laptop or desktop experience. So the thing here is that once you look at this device and what is the market share that the vast majority of people around the world are using that, of iOS or Android, what is the market share of the mobile OS? And that is, well, that according to Global Stats, this website that you can use for any small business owner to actually make more better decisions, okay, when it comes to actually provide that value to companies, or their service to companies. So here you can look at the world or the mobile OS worldwide use. So Android has 70.70%, 70.79%, iOS 28.46%, and that actually encompasses almost 99.99% of all devices, all mobile OS devices around the globe. So because of that, developing applications on Android and iOS, you have to have one particular code set, one particular development team, workflow, and also those applications work only on their platform. So you can run iOS apps on Android and vice versa. This is to a proprietary and the way how they create those kind of applications. So you also need to know is a particular language to build their applications there. Android or Kotlin in the case of Android, so Java or Android in the case of Jesus, Java or Kotlin in the case of Android, and Object-C and Swift in the case of OS. So because having two code sets and keep track everything with features and bug fixes is quite hard, not to mention OS updates. Because of that, companies like Facebook, they decide to have a go at it, decide to have a go at solving it. So this is when now React Native comes into place. So by having one single code base, one development team, one workflow, we can easily extend functionality. Now it'll make the development of these native projects, cross-platform applications, be way much more easy to do that. So that's interesting because this, and perhaps I'm quite biased, this actually streamline the development process, so you can now build applications that are indistinguishable without even touch the native code, perhaps at the beginning, and it is fully extensible, and it is open source for that. So the way how React Native works is by it target existing compilers. So by targeting the Android compiler to generate an Android artifact or another application, or the iOS compiler to generate is an iOS artifact, as well as Windows and other platforms, here React Native is doing that particularly well work. How does it work? Or particularly, what are the design patterns to actually communicate or targeting each one of them? The implementation detail can vary. So far, I haven't seen the code of how they're doing that. Maybe they're using some design patterns like the adapter, which it allows is two different objects to communicate. Okay, so the adapter here, and in this case, because each one of those compilers receive as an input is a project in that particular language, perhaps React Native is actually generating is that output. So that's great. Now that's a valid reason. That's also, is this also a question that I would like to ask to ChatGPT? Okay, is React Native generating inputs? Is React Native generated for generating the input? Is React Native generating native code for compilers? So right now I'm asking is, no, React Native does not generate native code for compilers. Instead, it uses JavaScript bridge to communicate with native models. Okay, JavaScript bridge to communicate with native models. Okay, so the using is the bridge pattern. Okay. So what is a bridge pattern, you might wonder? Glad you asked. So the using is the bridge. Okay. Okay. Interesting. Abstraction implementation sounds scary. Stay calm. And let's consider a simple example. Okay. Bridge is a structural design pattern that lets you split a large class or set of closely related classes into two separate hierarchies. Abstraction and implementation, which can be developed independently for each other. So what is doing the bridge is to split large classes or to split large code base into abstraction and implementation, which can develop independently for each other. Abstraction and abstraction and so the abstraction and implementation. Okay. Abstraction implementation sounds scary? Stay calm. Let's consider a simple example. Say you have geometric shape class with pair of subclasses, circle and square. Okay. You want to extend this class hierarchy to incorporate color. So you plan to create red and blue shape subclasses. However, since you already have two subclasses, you will need to create 4 class combinations such as blue circle and red square, shape, and this kind of 2. So blue circles and red square. So you have shapes, okay? Class with a pair of subclasses, circle and square. You want to extend this class hierarchy to incorporate colors so you can plan to create. So by having this shape here, you want to generate is this: red circle, red square, blue circle, blue square. Number of class combinations grow in geometric progression. Adding new shape type and colors to the hierarchy will grow it exponentially. For example, to add a triangle shape, you will need to introduce new class, one of each color, and after that, adding a new color will require creating the 3 subclasses, one for each shape type, and the further we go, the worse it becomes. So because the more things you need to add to this combination, this is when you have to this is when you have, in your case, because we wanted to deal with several compilers here, like this, alright, which is not actually useful to generate native code per each one of those platforms. Okay. This problem occurs because we're trying to extend the shape class in 2 independent dimensions by form and color. That's a very common issue with class inheritance. The bridge pattern attempts to solve this problem by switching from interface to the object composition. Okay. By switching to the interface, or by switching from inheritance to object composition. What this means is that you extract one of the dimension into a separate class hierarchy, so that the original class will reference an object of the new hierarchy instead of having all, if it is state and behaviors, within one class. Abstraction and implementation. Making even a simple change to a monolithic code base is pretty hard because you must understand the entire thing very well. Making change to a smaller, well-defined model is much easier. Let's try to solve this issue with a bridge pattern. It suggests that we divide the class into 2 hierarchies. Abstraction, the GUI layer on the top, and implementation, the operating system API. So multi-platform framework, and then you got is this demo 1.0, 2.0, 3, your app. One of the ways to structure a cross-platform application. Interesting. So the using is the bridge. The using is the bridge pattern for that. Okay. The abstraction object controls the appearance of the app. The abstraction object controls the appearance of the app, delegating the actual work to the link implementation objects. Different implementations are interchangeable as long as they follow a common interface. Enable the same GUI to work under Windows and Linux. As a result, you can change the GUI class without touching the API-related classes. Moreover, adding support for another operating system only requires creating a subclass in the implementation structure. So let me actually keep reading about this. Abstraction and implementation. The Goof book introduced the term abstraction and implementation as part of the bridge definition. The Gang of Four. Okay. The Gang of Four book introduced it. Okay, so let me actually, in fact, try to understand what is this particular pattern. Okay, so in the context here, okay, abstraction and implementation. So in this context here of the, let me keep reading about it. Okay, abstraction and implementation. The Gang of Four book introduced the term abstraction and implementation as part of the bridge definition. In my opinion, this turns some too academic and make the pattern seems more complicated than it really is. Having read the simple example with shape and color, let's decipher the meaning behind the Gang of Four book scary word. Abstraction, also called as the interface. So this is the interface. It is a high-level control layer for some entities. This layer isn't supposed to do any real work on its own. It should delegate the work to the implementation layers, also called platform. So the abstraction layer, which is the React Native, which is this high-level control layer, okay, isn't supposed to do any real work. They just only delegate work. It should delegate to work to the implementation layers or the platform layer. So this bridge or this way of how you can write your JavaScript application, okay. So this way, exactly, because it's used JavaScript bridge to communicate with native models. So the using right now is JavaScript as a way to communicate to native models. This allows you to, okay. So the bridge here is between the interface, which is in our case the JavaScript platform or the JavaScript code, and this is the abstraction or the interface, and then the implementations. How based on this interaction or how this code you're going to interact with, they're going to implement that. How they're going to be translated to those platforms. Know that we are not talking about interface or abstract class from your programming language. These aren't the same thing, exactly. When talking about real application, the abstraction can be represented by a graphical user interface, exactly. This is one of them. And the implementation could be the underlying operating system code, the API, which the GUI layers call in response to the user interaction. Is this abstractions calls so this abstraction or the JavaScript code call in response of how do we interact with that, how do we interact with this interface, this abstraction. Okay, so depending on which model we are using on the JavaScript layer, okay, we're going to it's going to communicate to the underlying layer, or in this case to this particular platform. Generally speaking, you can extend such an app into two independent directions. Have several different GUIs. Okay, have several different GUIs, for instance, tailored for regular customer or admins. Support several different APIs. Okay, two different directions, or have several different. Okay, or have several different GUIs, or have several different interfaces. Okay, or support several different APIs. This is something interesting from here, because now we're talking about is what is the underlying design pattern that React Native is using. You don't need to be too technical, but it's important to at least have good enough knowledge and intuition about what this thing is doing. Okay, so this is the two way of, or you can extend such app in two independent directions. This is the two common direction here. Or we can have several abstraction layers or several interfaces, okay, that communicate that could be underlying the implementations, or we can have is one of them, okay, that one interface that support multiple platforms or API. For example, to be able to launch the app under Windows, Linux, and macOS. In the worst case scenario, this app might look like a giant spaghetti bowl, where hundreds of conditionals connect different type of GUI with various API all over the code. You can bring order to this scale by extracting the code that relates to a specific interface, platform, combinations into separate classes. Okay, so when you say, hey, this UI or this abstraction, you can extract code from this abstraction and the implementation. In this case, you can abstract code which is for the JavaScript to the iOS, and then for the JavaScript to the Android. So you have now these two bundles here, or these two way of how they're going to interact, because it's the abstraction layer that delegates the work to the implementation of what it matters to the platform. Okay, so so imagine that you have your keyword here, okay, and in this keyword you want to interact with your and with this keyword you want to interact with, okay, yeah, so with this keyword you want to interact with the your Windows as well as your Mac. Okay, so the way how you interact with those is through some plugin, some interface, okay, some abstraction, which is the Bluetooth. And the way how the Bluetooth now is going to delegate the work is part of these as implementation details. So what this enables is for the user, we can now, by having one single interface, works in any places. So okay, so by having, so in the context of code is like by having now these single interfaces, or the single JavaScript interface, they have now a model or a code or a package for the implementation, for the abstraction and implementation, or the interface and platform to iOS, and as well as for the Android. Okay. Yeah, NewGui or supporting a different API will require creating more and more classes. So, however, soon you will discover that a lot of these classes, that there are a lot of these classes. The class hierarchy will grow exponentially because adding NewGui or supporting a different API will require creating more and more classes. Let's try to solve this issue with the bridge pattern. It suggests that we divide the class into two hierarchies. You divide your class, your representation, in two hierarchies. Okay, taxonomy. Okay, so you divide your class, you divide your class in two hierarchies. You divide your representation in two hierarchies: the interface and the implementation, or the abstraction and the implementation. And in the case of the GUI layer of the app, and implementation, the operating system API, pretty much like this. The abstraction object controls the appearing of the app, delegating the actual work to the link implementation object. Different implementations are interchangeable as long as they follow common interface. Exactly, different implementations are interchangeable as long as they follow a common interface. Enable the GUI to work under Windows and Linux. As a result, you can change the GUI classes without touching the API class related. Moreover, adding support for another operating system only requires creating a subclass in the implementation hierarchy. Okay, if you want to provide now, okay. If you want to provide, okay. If you want to provide is, okay. If you want to provide now support to other platforms, what you're doing is just create an abstraction and an implementation here. Damn son. As a bridge. An abstraction and implementation. Okay, this is the pseudocode. An abstraction and implementation. Hey, the client wants to, you know what? The client wants to do something. And in this case, it's for the remote control. So you have the remote, which is the interface that is exposed to the client. Okay, and then you have his okay, and then you have the implementation. Exactly, the abstraction. Okay, and then you have the implementation. If device enabled, device disabled, else device not enabled. Advanced remote. Exactly, and it's because this bridge can inherit or can extend or can interact here, because it's a client that wants to interact with the remote, and in remote expose certain interface that those interface is having an implementation of that. Hey, what are they gonna do about it? Volume down, volume up, get volume, set volume percentage. The base remote control class declares a reference field that links in it with a device object. All remotes work with the with the device via the general device interface, which lets the single remote support multiple device type. Multiple device type. Class remote control is applicability. Use the bridge pattern when you want to divide and organize a monolithic class. Applicability. Use bridge pattern when you want to divide and organize a monolithic class that has several variants or some functionality. For example, if the class can work with various database servers. A bridge. The bigger a class becomes, the harder it is to figuring out how it works, and the longer it takes to make a change. The change made one of the variation functionality may require making changes across the whole class. The bridge pattern lets you split the monolithic class into several class hierarchy. After this, you can change the class in each hierarchy independently of the class in other. This approach simplifies code maintenance and minimizes the risk of breaking existing code. So by using is the bridge, okay? By using is the bridge, what you're doing is to abstract or create another subclass. Okay, you're creating another subclass or another class hierarchy here to provide support to this. The bridge. Okay, what is the difference then with the adapter? So what is the React Native? So React Native is using behind the scene the bridge pattern. Hello. Okay. Exactly, but it's to facilitate communication between the JavaScript realm and the native realm. So by creating these subclasses here, or this hierarchy here, they say now instead of having just one monolithic class or one monolithic representation here of these gigantic objects, where you want is to now what you want is to give support. So instead of having one gigantic class that gives support to, in the case of React Native, that gives support to iOS or Android or Windows, in this gigantic class, they say, hey, well, let's gonna make a deal. Let's make a deal. Would it be better to split this functionality from this gigantic class, into hierarchies, okay, that when we need to maintain those particular code, it'll be much better because we split them into their own hierarchy, into their own self-contained code. So this is part of the modularization. So bridge, can we say that bridge pattern aims to split code into modules to organize and keep code maintenance better? What the flying fuck? Okay. Yes, you can say that. The bridge pattern is a structural. Makes sense. The bridge pattern is a structural design pattern. Okay. That aims to decouple an abstraction from its implementation. That it aims to decouple is the interface from the implementation. So regardless of implementation, I want you to abstract them into our own interface. So the interface and the implementations can be in their own model. In other words, so instead of having one gigantic monolithic application, here we can have is on the single package is, well, one model for JavaScript and iOS, whether it is for Object-C or Swift, okay, which communicates to them, and the other is the JavaScript and Android. But the whole point of this is to help them organize code for maintenance. And this is a structural way of doing that. So instead of having this gigantic, so instead of having this uh, so for example, instead of having a gigantic pile of paperwork, let me split that in categories that are relevant. Okay, because in that way I can now do that work, which is maintain this particular code much more easy and that kind of thing. All right. Okay. Okay. Exactly. The bigger the class becomes, the harder it is to figuring out how it works. It's like, what the fuck is doing this? And the longer it takes to make a change, and the longer it takes to make a change, the change may, the one of the variation of functionality may require making changes across the whole class, which often result in making errors or not addressing some critical side effect. The bridge pattern lets you split the monolithic class into several class hierarchies. After this, you can change the class in each hierarchy independently of the classes in the other. This approach simplifies code maintenance and minimizes the risk of breaking existing code. Use the pattern when you need to extend a class in several orthogonal or independent dimensions. Exactly. Hey, this class, I need to create a fork on this independent dimension. I need to provide a support for this. Okay, orthogonal. The bridge suggests that you can extract a separate class hierarchy for each of the dimension. Exactly. So the bridge suggests that you extract a separate class hierarchy for each of the dimension, and the original class delegate that related work to the object belonging to those hierarchy instead of doing everything on its own. Use the bridge if you need to be able to switch implementations at runtime. Interesting. Although it is optional, the bridge pattern lets you replace your implementation object inside the abstraction. It is easier than assigning the new value to a field. By the way, this last item is the main reason why so many people confuse the bridge with striated pattern. Remember that a pattern is more than just a certain way to structure your class. It may also communicate intent and problem being addressed. Bridge and striated. The other is the adapter. The bridge and the adapter. It's an structural design that allows objects with incompatible interface to collaborate. Okay, so now things is starting to make a lot of sense. So the bridge is a design pattern to split. Makes sense. Okay, this is the action. So the bridge is a design pattern that allows you to split large classes into a set of related classes with their abstraction and implementation. In other words, it allows you to split and organize your code so you can make change more faster and maintain it as well. Okay, this is the bridge. Okay, let me split this by commonalities. Okay, making it much more easy to work with. Whereas the adapter, it allows two objects or two classes to communicate each other. The perspective here is this, because we're now looking at the okay, and I get it why a lot of these people, especially companies on the US, Canada, UK, are looking for people that actually can understand this, because the value of this lies is on the way of how you can organize and follow. Okay, how can you split organize as a way to make your code much more maintainable. So that's what you have is the creational pattern, which is something that I'm quite familiar with. Totally, I am quite familiar with. So you got the factory, you got the abstract factory, and singleton. All right, okay. I'm not that familiar with the builder and the prototype. Unless you copy existing objects without making your code depending on their class, which is something that is used on JavaScript, the prototype. So it allows you to create clones of your objects without depending on their class. Okay. So all of this is for, so we have to imagine code. Damn, so we need to imagine code as Lego blocks, pretty much. Anytime you write in software engineer live a hell of abstraction, bro. Software engineering live a hell of abstraction. Totally, man. Oh my god, yeah. So that makes a lot of sense. That makes a lot of sense. Okay. It's okay. Totally. Okay. So these design patterns are common ways. So the design patterns are common ways to solve. The design patterns are ways to solve common problems. That's what it is. That's what is a design pattern. Okay. It's a way to solve. It's a typical way to solve common problems. I like it. So for example, where are your keys? Where's your mobile phone? You always lose that thing. So the thing here is that, okay, how can I find a common solution for this particular problem? Well, that's what we have is in your houses, all of these key tenders. It's okay. Okay, so this is the design pattern. The design patterns are typical solutions to common problems. And in this case, in the software design, okay, it's actually not that hard. It's actually not that hard. However, you can, because, for example, anytime you want to eat pasta, you use a fork. That doesn't mean that when you eat soup, you should eat with a fork. You know what I mean? And again, that's what happened. So there's also the tractors. There are There are benefits of the pattern. Okay, there are also some detractors, because it's like it can lead you to some common problems. And the classification here. And the classification here. I think this is something very, very, very interesting that I don't know if people actually put attention and energy to learn about this, but generally, refactoring good, because quite frankly, it's like, man, try to understand that genuinely. And when someone actually, or when someone asks you for this, it's like, okay, this is it. And then you can use a real life example from that. I think this is my particular way of how I learn things, how I do the things that I do, in a way that help me to organize my ideas, as well as my thinking process. So yeah, okay. So things started to make a lot of sense. Things started to make a lot of sense. The interesting here is that by asking questions, you're slowly gonna make your connections. But you need to ask those questions, and you need to do that genuinely, right? It's like, okay, what is this? How is this? As you can see, how you're going to, how you plug in things internally in your mind, how you're gonna make all of these neuronal connections. Okay, okay, all right. So it all starts by understanding is how React Native actually works. Okay, because it targets existing compilers. But how? You know, uh, the way that it target is by, if you allow me to lead more, if you allow me to let more, if you allow me to lead, oh my god, if you allow me to be more explicit, but in a short term, is this. So this design pattern, or in this case, in the case of React Native, by targeting is existing compilers. In the way how that works is by saying, hey, I'm going to expose is a JavaScript interface that you can interact, that you are familiar with, okay? But behind the scenes, I'm going to have is the implementation, which is going to communicate to the existing compilers. And because of this, and as a way to make your life, especially for the React developers, the bigger your code is, in this case is, the bigger your code is for handling the Android and iOS, and especially because when you come out with, or when those OS come out with other solutions, okay, or not new features, you also need to provide support, okay? So because of that, and the attention right now is on these particular devices, on mobile, because it's something that you can actually have in your daily days. You can access quickly. You can browsing. Most of the time, we use that by browsing the web or looking at social media and that kind of thing. But in any case, the thing here is that the way how that works, you can imagine that how you're going to maintain such amount of line of code, the bigger it grows. So by using is the bridge design pattern, is that, hey, let's go to split this gigantic code into subclasses, into a hierarchy of subclasses that has common things, and from there we're going to do that as a way to expose that. as a way to expose that to whoever it needs to be used. So in other words, is that by splitting your code base with common things in each one of those, by splitting things in each one of those subclasses, you can now make your code much more easy to maintain and adding change to that. So the way how that works is by having this interface or the abstractions, the public facing or the face of how you can implement that. You can have is the abstraction or the interface as well as the implementation, and they are going to be grouped together in their own domains based on these subclasses. So this is something interesting because, for example, if you want to build is a GUI interface or a user interface, as well as provide support to the APIs, you can say, okay, I have this particular API, for example, the server that I want to now serve to multiple endpoints, or in this case, to the mobile, to the web, to the tablet, right? So this is one particular way of doing that, and the other, in our everyday lives we're actually using is a bridge. Yeah. And the other is like, okay, so I want from this particular interface, for example, in the case of the mobile, okay, I want now to talk to my bank, as well as I want to talk to my bank. I want to talk to my e-commerce. I want to talk to my government or my utilities application, right? So this is another alternative. But again, all of those interface or all of those API must share that commonality. But again, this is a structural pattern. Structural pattern because yes, it allows you to split and organize your code. Once you have a big, it allows you to organize, it allows you to split and organize large code bases. Okay, so large code bases into a subclasses that are related to each other, making it much more easy to maintain and making it much more easy to maintain. So we can assume the abstraction from the native platform code, the implementation, and this allows developers to write JavaScript code without worrying about the specific of the native platform, worrying about it. And it allows change to the native code without affecting the JavaScript code. And it allows to change the native code without affecting the JavaScript code. This separation can make the code easy to maintain and extend. Exactly. So the TLDR is React Native generating the input for those compiler? No. It just or it communicates to those exactly, because one thing is like, hey, are you going to generate input? Are you going to generate the input for that? Okay. Okay, no, I'm not going to generate the input for that. In fact, what I'm going to do is to communicate to the implementations to generate that, to generate the code. In this case, to generate is the Android, iOS, and that kind of thing. Okay, so is React Native generating the input for those compilers? No, it communicates. No, the abstraction or interface, the abstraction of the JavaScript layer. Okay, so the abstraction of JavaScript layer interact exactly the abstraction of JavaScript layer target the abstraction of JavaScript layer target the existing compilers. Okay, it might use the bridge pattern. Okay, it might use the bridge pattern, like this. So yeah, it might use the bridge pattern to split the code base into hierarchies, or into subclasses, hierarchies. Okay, so it can split. Okay, it might use a bridge pattern to split a huge code base into subclasses, hierarchy relevant each other, split large class or a set of closely related class into two separate hierarchies. Exactly. So into two separate, exactly. Where is this? Is this? Exactly. It allows you to split a large class or a set of closely related classes into two separate hierarchies. Abstraction and implementation, which can develop independently of each other. But this is what allows you to do this. Okay, it might use a split plat. Exactly. It might use the bridge pattern. So instead of having a huge code base, it split it on subclasses. Exactly. It's split it on subclasses. Okay, so it split it on subclasses. Exactly. So instead of having a huge code base or subs or a set of related classes, it split into two hierarchies. The abstraction or the interface, the abstraction / the interface, JavaScript, or the and the implementation. That can be developed independently. independently. So why this is important? Because especially the more you're going to dive deep into the code and to provide solutions to other companies and to provide value, you're going to find out very quickly that you're going to need to know how this design pattern works. Okay, and what is the goal of this design pattern? So, for example, in the case of bridge, which is an instructional pattern, okay, the whole point of this is to allow you to make your code base much more easy to maintain by splitting is a huge large code or a set of code bases related to each other into a hierarchy with interface and implementation that can be developed independently. That's the whole point of this. So instead of having to generate is React Native input for Android and then compile that, no. Let me actually the build tools generate that for us. Let's actually the compiler actually do that for us. I'm just going to create is this interface, okay, for JavaScript developers so they can have access to native features per platforms as well as the build tools. Okay, makes a lot of sense. Yeah, totally makes a lot of sense. Yeah, okay. I think that was quite interesting. So with that, that'll be all for this video. Take care. Bye bye.